We are still on circuit geometry, and we have this question here. Find the sizes of the angles of A, B, C, D in this circle, where O is the center. So we have this O here to be the center. Now, which angle are we looking for? We want to get the angle here, angle B here. Okay, that is, we want to get the angle B here. We want to get the angle A. We want to get this, and we want to get this one entirely. Okay, we want to get that. So now what are you going to do? What are we going to do? So now from here, okay, now let's look at this. What are we going to do here? So now for the fact that BC, this, because this one is the center, it means this BC towards to D like this is diameter. So now if this is diameter, so now look at the angle that this thing subtend. I mean the diameter subtend from this side. You see that if you place your hand there and go through like this A, so it means this place is what? This place is 90 degree. So do you understand now? So we have this to be 90 degree. So therefore we're going to have in what? In quadrilateral, in quadrilateral A, B, C, D. Okay, A, B, C, D. Okay, so this what you can see that BAD, one of the angle we are looking for, is going to be 90 degrees. The angles in or angle in a semicircle, in a semicircle. Okay, could be AD. Then if you look at this, so if you look at this BCD, that is BCD, this is also, this is the diameter. So if you look at this from here now, this line diameter subtend the angle at the circumference here. See, it means this one also is 90 degrees. So BCD is also 90 degrees. So now the same what? Same reason as this one here. Are you getting it? Now we have this already. We have this already. Now we need this angle and this angle here. This angle B, everything here, and we need this angle here. So now this angle we can get ADB. ADB is same thing as 33 degrees. Okay, now let's see why it is 33 degree. If you place your hand here, going this way, going this way, going this way, can you see? So now from these 2 points here, can we travel to this E here? Yes, we can travel to it. So we're going to see that from here, travel to this, we see 33 degree there. So it's telling us that this angle here, 33, this angle here is what? Is angle, and this angle, they are what? They are found in the same segment. They are found in the same segment. If you look at this, this is the what? This is the chord that connect them, AB here. I get it now. But look at this. This chord subtend this angle here and also subtend this angle 33 degrees here. Do you understand now? So we show that this angle and this angle are found in the same segment, and that is why this place is 33 degrees. So ADB, this angle here is 33 degrees. So we have what we said, angles in the same what? In the same segment. Are you following? Now the next one we are going to do, you can see the question is very interesting. So now the next one we are going to do is now I need this angle here, okay, and I need this angle. I need this angle here. So what are we going to do? What are we going to do? So now here I want to get this angle here. To get this angle here, this angle, this is what I'm going to do. Look at this BC. This BC subtend an angle at the center, which is 76 degrees, and also this BC subtend an angle here at the what? At the circumference. So which means BDC, that is this angle BDC, this place here, will be equals to what? 76 degree divided by 2. That is, the angle at center is twice the angle that is subtend. This chord subtend at the circumference of the circle, because this chord subtend this angle at the center and also subtends another angle at the circumference. So therefore, this will be half, this will be twice of this, so this will be half of this. So that's why we have 76/2, and that will be 38 degrees. So now the reason is that angle at center twice the angle at the circumference. You can see everything here will be what? 36 degrees. Now I want to know this angle here. If I should get this angle here, now you know that if I complete this angle 33 plus 36 together, so we are going to be having what? This is going to be altogether, we're going to be having 33 plus 36, and that will go to be for us 69 degrees. If this is 69 degrees, you should know that this angle D, that is ADC, okay, plus ABC will be equals 180 degrees. The reason is that the opposite angles of cyclic quadrilateral are supplementary. So that is opposite angles of what? Of cyclic quadrilateral. So now here ADC is 69 degrees, plus ABC, which is angle B that we are looking for, ABC. So it's going to be ABC equals 180 degrees. So ABC is now going to be 180 degrees minus 69 degrees. So we have ABC to be equals. Now remove 69 from 180. What are you going to have? Oh, I'm sorry, we made a mistake here. This one is 38, not 36. I put 36 here. So this is 38. This is 38 degrees. So now what we are going to be having is not going to be 69. That is going to be what? That's going to be 71. I'm really so sorry for that. I'm really so sorry. So 71 degree, everything here will be 71 degree. So here that I put 69, it's going to be 71 degrees. Here also is going to be what? It's going to be 71 degrees. I'm very sorry for that. So now 180 degrees minus 71. From there, I'm going to have 109 degrees. The angles that we are now looking for is now going to be the angles ABCD, ABCD. They are now going to be, for this is going to be 90 degrees. That is for A. For B, everything here as we got here is going to be 109 degrees. Then for C here is also 90 degrees, and for D, which is everything here, is going to be 71 degrees. And these are the 4 solutions, right? So if you enjoy this class, please help us to share this, okay, so other learners can also, other learners can benefit from it. Share this for us, please. And if you have not followed our page, consider to follow today so that you enjoy more of our amazing class. So what I discover is that you don't share our classes, please, so that we can have, you can encourage us to give you the best. Thank you so much for watching. Bye bye.